What if the most powerful space telescope ever built just dimmed our hopes for finding life while raising the stakes higher than ever? Imagine if one discovery could change not just our place in the universe, but the future of every mission and dollar spent on space exploration. For decades, scientists have hunted for a true Earth twin. The TRAPPIST-1 system, with its 7 rocky planets, was seen as our best shot. Each world is about the same size as Earth, but one, TRAPPIST-ONE-D, looked like the golden ticket, sitting in the habitable zone, possibly with water, air, and just maybe life. The James Webb Space Telescope targeted TRAPPIST-1-D, hoping for a historic breakthrough. Instead, astronomers found nearly nothing. As one expert put it, scientists did not find a robust atmosphere around TRAPPIST-1-D, an Earth-size exoplanet many hoped would show signs of having air. Worse, the study did not prove the planet is bare. It simply left us in the dark. The telescope ruled out some possible atmospheres, but not all. Now, we are left with more questions, and the odds of a nearby Earth-like world suddenly feel much slimmer. As our telescopes get sharper, the dream of finding another Earth seems to fade. Are we searching the wrong stars, or missing the real clues to life? Every dead end costs us precious time, resources, and may even blind us to where life actually hides. Let's break down why astronomers pinned so many hopes on TRAPPIST-1 and what this setback really means. But while TRAPPIST-1 raises doubts, a new development at Alpha Centauri could change everything. First, let's see why the stakes around TRAPPIST-1 were so high. Imagine holding 7 tickets for the cosmic lottery, each one a shot at discovering another Earth just next door. 8 years ago, astronomers found the TRAPPIST-1 system, 7 rocky worlds, all about the size of our own planet, circling a dim red dwarf star only 40 light-years away. If even one of these planets turned out to be habitable, the implications for humanity would be enormous, shifting the future of space exploration, scientific funding, and our very sense of belonging in the universe. The discovery sent shockwaves through the scientific community. Not only were all 7 planets Earth-sized, but several orbited within the so-called habitable zone, the region where temperatures might let liquid water exist. If any of them had real atmospheres, the stakes were clear. We could be on the verge of proving that life-friendly worlds aren't rare, but scattered throughout our galaxy. TRAPPIST-1's host star is a red dwarf, the most common star in the Milky Way. If these planets could hold on to their atmospheres despite savage stellar flares and relentless radiation, it would mean habitable worlds might be everywhere. The prize? A cosmic jackpot that could redirect decades of research, billions in investment, and humanity's dreams of finding life. The risk? If TRAPPIST-1 struck out, our best hope for a nearby Earth twin could vanish, forcing us to rethink everything. When the James Webb Space Telescope finally launched, anticipation hit a fever pitch. Webb's ultra-sensitive instruments promised to detect even faint atmospheres by searching for missing colors in starlight through transmission spectroscopy. With every observation, scientists hoped to catch hints of air, water, or even the fingerprints of life itself. But reality hit hard. Webb targeted TRAPPIST-1-D, a standout candidate right at the edge of the habitable zone. After sifting through interference from star spots and tricky signals, the result was crystal clear. No strong signs of atmospheric gases. This matched earlier, disappointing results from TRAPPIST-1b and C, planets even closer to their star. Each strike chipped away at the dream that a second Earth was hiding so close to home. It's not about hoping for a yes. It's about finding what's real. One lead scientist admitted. 3 planets down, and the odds of finding a truly life-friendly world in our solar neighborhood grew slimmer. The hope that TRAPPIST-1 would change everything seemed to fade, until the data revealed something no one saw coming. But just as hope for TRAPPIST-1 was slipping away, a new discovery stole the spotlight. Evidence pointed to something extraordinary in the Alpha Centauri system, our closest sun-like neighbor. What if the universe's most promising Earth-like worlds are already slipping through our fingers? With a single announcement, the James Webb Space Telescope has put our dreams and billions in future exploration on the line. Webb's unrivaled precision didn't reveal a lush living planet, but a chilling absence, not a trace of atmospheric gases. For years, the TRAPPIST-1 system was our golden ticket, a tightly packed family of 7 rocky planets, each close to Earth in size, circling a nearby red dwarf. Hopes soared that these worlds might shield atmospheres, oceans, or even life itself. But Webb's latest findings have landed another gut punch. After meticulous observation of TRAPPIST-1, the third planet from its star and a top contender for habitability, Webb found no sign of air. Researchers now conclude TRAPPIST-1 is unlikely to have air. That makes 3 strikes. Previous data showed TRAPPIST-1-B and TRAPPIST-1-C also came up empty-handed. This isn't just bad fortune, it's a warning. Webb used transmission spectroscopy, timing each planet's passage in front of its star. If TRAPPIST-1 clung to even a wisp of atmosphere, molecules like water vapor or methane would have etched their fingerprints into the starlight. Instead, after scrubbing out noise from stellar spots, the data came back silent. No gases, no hope. The consequences ripple far beyond this single world. TRAPPIST-1 orbits in the habitable zone, the region where lakes could shimmer and oceans might roll. Its barren state hints that these planets, assaulted by fierce stellar flares from their red dwarf sun, may be stripped to the bone. If that's true, the most abundant stars in our galaxy might be far less welcoming than we dared imagine. Yet the letdown only sharpens the challenge. Webb is battling the odds. These worlds are not just remote, but orbit a dim, tempestuous star, making atmospheric signals far harder to spot than for planets around sun-like stars. Even the most advanced telescope ever built faces hard limits when nature is working against us. Now, the scientific community is wrestling with uncomfortable questions. Are we searching for Earth twins where none will ever be found? Could our narrow ideas about habitability blind us to stranger, unseen possibilities? Each failed detection threatens not just scientific frustration, but public disillusionment and wasted resources, forcing us to reconsider what exactly we're hunting for in the cosmos. And just as the door to TRAPPIST-1 seems to be closing, an unexpected new window has cracked open, astonishingly close to home. What if the next breakthrough isn't light years away, but right in our cosmic backyard? Webb's gaze has turned toward Alpha Centauri, and the results might upend everything. What if the closest shot at finding life beyond Earth has been hiding in plain sight, just a few light years away? Ignore this, and we risk missing the most important neighbor in the entire galaxy. Just as hopes faded for one star system, Webb spotted something astonishing, a new signal from Alpha Centauri, only 4 light-years from us. While astronomers were absorbing the tough news about the TRAPPIST-1 planets, the James Webb Space Telescope shifted its gaze to our own cosmic backyard. Alpha Centauri, home to the nearest sun-like stars, has been the subject of wild speculation for generations. Yet, for decades, every attempt to find planets there came up empty. That changed dramatically with Webb. This time, Webb's sensitive instruments picked up a faint but persistent signal. According to Space.com, astronomers using NASA's James Webb Space Telescope have found strong evidence for a new exoplanet, one orbiting Alpha Centauri A. For the first time, we are glimpsing direct hints of a planet circling a star eerily similar to our own sun, and astonishingly close on the cosmic scale. What truly electrified scientists was the planet's location, right in Alpha Centauri's habitable zone, where temperatures could allow liquid water, a prerequisite for life as we know it. Live Science called it the closest alien planet to Earth that orbits in its star's habitable zone. This is not just another frozen gas giant or scorched wasteland. Its orbit, at least on paper, could be a place where the ingredients for life might assemble. KISS FM reported that Webb has detected the strongest evidence so far of a giant gas planet orbiting Alpha Centauri A just 4 light-years away. Astronomers estimate its mass could rival Saturn, circling its star at a distance between 1 and 2 times that of Earth's orbit around our Sun. Sky and Telescope even noted that Webb's direct images show what could be a Saturn-mass planet orbiting Alpha Centauri. If confirmed, this discovery would upend long-held beliefs. For decades, the search for habitable worlds has zeroed in on small, rocky planets like Earth. Now, with a giant planet potentially sitting in the habitable zone of our closest sunlight neighbor, the rules have changed. Could life thrive on moons orbiting such a planet? Have we been overlooking the best places to search for habitability, gas giants in sunlit zones, while focusing on rocky planets around dim, temperamental red dwarfs? The stakes are enormous. A planet like this could trigger a tidal wave of investment into new missions, bigger telescopes, even the first interstellar probes, billions of dollars, and entire scientific careers redirected by a single paradigm-shifting clue. For every theory built on the idea that only Earth-sized worlds matter, Webb's find is a wake-up call to widen our search and challenge our deepest assumptions about where life might take hold. So, what does this mean for the search for life? And what must we change if we want to seize this unprecedented opportunity? To make sense of this breakthrough, we need to rethink our priorities and confront the new questions Webb's discovery has unleashed. Here's what's at stake in the next phase of the search. Maybe our obsession with finding Earth 2.0 is actually holding us back, and the real lesson from the James Webb discoveries is that we need to expand our horizons. For years, we have focused on searching for worlds that are just like our own, the same size, temperature, atmosphere, and orbit. But as the Webb telescope's look at the TRAPPIST-1 system shows, nature does not owe us a carbon copy of Earth. The search for air around TRAPPIST-1-D came up empty, but scientists note that it could have an extremely thin atmosphere, so the latest study didn't prove it was bare. This is not failure. It's a milestone. As lead researcher Piolet Gorayeb put it, for the first time, if there had been an Earth, in other words, our instruments are now sharp enough that if a true Earth twin were there, Webb would have sensed it. The absence tells us not to give up, but to rethink the blueprint for habitability. Webb's results are already helping scientists peel back the layers of cosmic noise. Astronomers have, for the first time, captured the spectrum of a magnetic feature on the cool red dwarf TRAPPIST-1. This breakthrough offers a way to reduce the stellar noise that often drowns out the faint signatures of alien atmospheres, opening new doors to studying even stranger worlds. At the same time, Webb has delivered the strongest evidence yet of a giant planet in the habitable zone of Alpha Centauri, our nearest Sun-like star. These findings, as experts note, could transform what we know about Alpha Centauri and about what kinds of planets might offer homes for life. If we keep clinging to narrow, Earth-centric ideas of habitability, we risk missing out on worlds that are truly bizarre, but still potentially life-friendly. The future of the search for life in the universe depends on expanding our definitions and our expectations. So, given all this, what should our next move be? And how should scientists and the public adjust their hopes for the search ahead? Webb did not serve us an Earth twin, but it forced us to ask better, bolder questions. For years, we dreamed of finding a second Earth among the TRAPPIST-1 planets. Yet, the James Webb Space Telescope has now shown that TRAPPIST-1-D, like its neighbors, is unlikely to have an atmosphere. 3 strikes. No clear air, no blue-green promise, no easy answer. But here is the plot twist. This supposed failure is actually a revelation. Webb's instruments, while ruling out one story, have opened the door to new ones, spotting hints of a giant planet in the habitable zone of Alpha Centauri, our closest sun-like neighbor. Instead of handing us a mirror image of Earth, Webb is revealing an unexpected diversity of worlds, from barren rocks to Saturn-sized giants riding the edge of habitability. We now stand at a crossroads. If we cling to the idea that habitability means only an Earth copy, oceans, blue skies, familiar chemistry, we risk missing the universe's real surprises. The lesson from TRAPPIST-1 is this: the cosmos is not obligated to give us what we expect. Our search for life must be broader, fueled by curiosity rather than nostalgia. So, let's update our mental model. What if life is stranger, rarer, or more resilient than we imagined? Instead of looking for Earth 2.0, we should be searching for another world in all its forms. Webb's biggest gift may be humbling us, pushing us to ask different questions, and reminding us that the journey of exploration is about discovery, not confirmation. The universe is not done surprising us. So what might our next bold questions be, and how can we stay ready for the unexpected?